Welcome to Mr. Baker's House of Knowledge. We're going to pick up with Unit 3 here. So one of the things I want to review for you first with Unit 3 is I want to talk about the parallel and the skew and the parallel planes, just to kind of review from that. So parallel lines are coplanar. Parallel lines are coplanar. And so what that means is there are two lines that lie in the same plane, but they won't cross. So for example, AD and BC are both in this plane, this top thing of this cube, but AB and DC, or I'm sorry, AD and BC will never ever cross. Neither will AB and DC for that matter. So that's what parallel is. Skew lines are lines that are not coplanar, that do not cross. So for example, we've got AE up front here, and this is like a vertical line that goes up and down, and it's in the front plane and the left plane. But then we've got FG over here that's in the bottom plane and the right plane, and it'll never cross with AE. So FG and AE are examples of things that are skew. The slide here gives AB and CG as examples that are things that are skew. So does anybody have any questions about what a parallel line is and what a skew line is? All right, and then parallel planes. Parallel planes are planes that do not intersect. So some examples we might have are the top and the bottom of this box, the floor and the ceiling. Opposite walls are usually parallel planes. So parallel planes are planes that do not intersect. Any questions on that? All right, cool. Let's move on. So what I want to be able to do right here is I want to find non-intersecting lines and planes. Just kind of a quick review of how that works. So which segments are parallel to AB? So if we look at AB, AB is this line right here. I want to find out which segments are parallel to that. And there's actually three other segments that will be parallel to that. So if you look at AB as being in the left side of that rectangular figure, then EF is coplanar with that. EF would be parallel. If you look at AB as being in the top, DC would be parallel. And technically, you could put a little diagonal divider. If you think about this as being a box, and you think about having like a sheet of cardboard, you could stick a sheet of cardboard in there, and one edge could rest on AB, and the other edge could rest on HG, or GH. So there are three, in this picture, there are three lines that are parallel to AB, because there's three lines that could be coplanar. Does anybody have any questions about that? All right, and then we have the situation about skew. Which segments are skew to CD? So CD is this line segment here, and we're going to pick out all the things that are skew. All right, usually skew means running in a different direction. However, we're wanting to run in a different direction, but we're also wanting to be not coplanar. So if I did DH, DH lies in the same plane as CD. So I can't do DH. However, I can do AE, I can do BF, and if I tried to do EF, I could stretch that diagonal thing of cardboard there. So that's not going to work. However, FG is not in the same plane as CD, and EH is not in the same plane. Okay, so all the ones that we would have marked parallel to CD we exclude, and then we look at all the other lines basically that don't intersect CD. Does that make sense? All right, so that's parallel and skew. What are two pairs of parallel lines? Well, or I'm sorry, what are two pairs of parallel planes? Well, basically, if you look at this figure right here and you look at the top and the bottom, the left and the right, the top and the bottom are going to be parallel to each other. So plane A, B, C, D is parallel with plane E, F, G, H. Plane AEFB is parallel with plane DHGC, and plane ADHE is parallel with plane BCGF. And you could also have a line segment parallel to a plane. For example, any line in plane EHGF is going to be parallel to this plane up here. So line EH is parallel to this plane up here. But line EG, which isn't even pictured, is also parallel to that plane up there. So lines can be parallel. So basically any line in a plane that's parallel to another plane, that line will be parallel to the plane as well. Any questions about that? All right. What I want you to do on a sheet of paper real quick is I want you to jot down, in looking at this figure right here, I want you to jot down the answers to these questions. All right, and we're back, and hopefully you've had some time to decide what your answers are on this particular problem. So, which segments are parallel to AD? So I need to find line AD. And line AD, it looks like, is going to be right here. So there's more than one correct answer, of course, to which segments are parallel to AD. If you put, Kristen, what did your group get? BC will work. Faith, what did you guys get? EH will work. Did anybody get the other one? What? FG, good. So either EH, FG, or BC is okay to be parallel to AD. Did anybody find a line other than those three? Good. Okay, why is FE and CD not skew? So let's take a look. FE would be this line right here, and CD would be this line right here. Why are those two lines not skew? Why are they in the same plane, I guess is my question.
They're diagonal to each other.
Yeah, so I mean I could kind of, if I connected E and D and I connected F and C, that kind of makes a little polygon type shape, a little parallelogram type shape, which to me kind of indicates that they're in the same plane. So even though the plane that they shared was not drawn, it could still exist. Who got a set of parallel planes? All right, Emily, what'd you get? Yes. A, B, C, D, the top, and E, F, G, H, the bottom. That works. Anybody get something different? What'd you get? B, A, E, F is the left side. And what was the other thing you said? C, D, H, G? Yeah, C, D, H, G is the right side. So the left side and the right side are definitely parallel planes. And then finally, what two segments are parallel to the plane DCGH? So DCGH is this side of the box over here. There's more than two segments. AB would be parallel, BF would be parallel, FE would be parallel, AE would be parallel. So any line segment that's on the parallel plane to this plane, you're good. Does anybody have any questions? Excellent. Let's move on then. All right. So the key to Unit 3 is we're going to start talking about the relationships between angles formed by two lines and they're transversal. So a transversal is just a fancy word that means I drew a line that crossed two other lines. It transversed or intersected two other lines. Now, from this picture here, how many angles do you think are formed when you cross two lines with another line? 8. So how many lines are formed when you just intersect two lines? How many angles are formed when you intersect two lines? 4. So basically every other line you cross, you're going to pick up another 4 angles. So this has 8 angles. And this is basically the figure that we're going to be dealing with for the next unit. Is this 2 line crossed by a 3rd line forming 8 angles situation. Now, if you'll notice in this picture, you can identify which one is the transversal. It's the one that crossed the other 2 lines and was instrumental in forming the 8 angles. Now, I know that eventually these lines will cross. Later on, we're really going to be dealing with just parallel lines cut by a transversal. So you can have the lines not parallel, but you can still identify the transversal based on how the angles are written. So the transversal will touch every single angle. So notice in this picture, T is the transversal because angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8 all touch T. And then the non-transversal lines, the other 2 lines that got cut, were lines L and line M. Does that make sense? All right, so T is my transversal. L and M are the other 2 lines. And then we have this thing called the interior and the exterior. So interior is a word that means kind of like inside, and exterior is a word that kind of means like outside. So inside is all of the area in between the two lines that are not the transversals. Outside is all the area that is not in between the 2 lines that are not the transversals. So the blue area is the exterior, the green area is the interior. How many angles do you see in the interior? And how many angles do you see in the exterior? So we're going to refer to interior angles and exterior angles in relationship to the 2 lines that are not the transversal. And we're going to be working with the relationships. By the way, we already know some relationships. What's the relationship between angle 2 and angle 4? And what do we know about vertical angles? What's the relationship between angle 1 and angle 4? Why are they supplementary? Because they're... What's the word we use for that? Linear pair. So angle 1 and angle 4 are linear pairs. What do we know about linear pairs? They're supplementary. Linear pairs are supplementary. Yes, they share a side. They also, so they're adjacent angles that are supplementary. That's what a linear pair is. They're adjacent angles whose non-adjacent side forms a line. That's the definition of a linear pair. And linear pairs are supplementary. So what could I say about angle 5 and angle 6? What did I say about angle 1 and angle 4? So what's angle 5 and angle 6? They're linear pairs. That's the word I'm looking for you to describe it. That's the word you'll be putting in proofs, is measure angle 5 plus measure angle 6. Or angle 5 and angle 6 are supplementary. Why? Linear pairs. And then measure angle 5 plus measure angle 6 equal 180. Why? Definition of supplementary. Angle 2 and angle 4 are congruent. Why? Vertical angles are congruent. I'm okay with you not having the level of rigor where you just say the measure of angle 5 plus the measure of angle 6 equal 180, and then you can just put linear pairs. Because that'll always be true. Linear pairs are supplementary. Supplementary means 180. So I'm okay with you putting that one reason there. Everybody okay? Any questions? All right, let's move on. So in this figure up here at the top, what is the transversal?
Line T.
Line T. What are the 2 lines that are not the transversal? Line L and line M. All All right, so we're going to look at a special relationship like vertical angles, like linear pairs, but it's something different. It's something new. And this is called same side interior angles. So same side interior angles are angles that are on the same side of the transversal. So if you look at line T, it has a left side and a right side. What are the ones on the right side? What are the angles on the right side of T? What else? I see 4 angles on the right side. What are they? 2, 3, 6, 7. What are the 4 angles on the left side of the transversal? 1, 4, 5, and 8. With relationship to that picture, what are the 4 angles that are in the interior? 4, 5, 3, and 6. All right, Faith, you with me? All right, so we've got angles in the interior and angles on the same side. So to be on the same side and the interior, you have to either be angle 3 and 6, their same side interior, or angle 4 and 5, their same side interior. You absolutely can't use angles 1, 2, 8, and 7 because they're not in the interior. So they will never be part of the same side interior. Are we clear with that? Anna, you with us?
You said that like 3 and 6 are on their side of the interior and 4 and 5 are on their side of the interior. How do you know which one you're using? If you're like
So if I were to ask you, what's the relationship between angle 3 and angle 6, you would say same side interior. If I were to ask you what's the relationship between angle 3 and angle 2, you would say linear pair. If I were to ask you what's the relationship between angle 1 and angle 3, you'd say vertical angles. So right now we're just talking about how they're related. I'll get to what you do in a proof in a second.
Okay.
All right, so we've got same side interior angles. Now we're going to talk about corresponding angles. Corresponding angles are like if I took one of the lines and slid it up and rotated it, what angles would be overlapping the other angle? So let me just kind of do that here. So what I'm going to do is I'm going to take a picture of this one right here. All right. So here's this little angle thing. I'm going to make it a little bit bigger. All right. Now, the question is, if I take this thing and I rotate it to where it's parallel to the other one, and then I slide it up there, what angles overlapped? So what do you think's overlapping with angle 6? What do you think's overlapping with angle 5? 1. What do you think's overlapping with angle 8? 4. What do you think's overlapping with angle 7? 3. So that's how you know if something is corresponding. If they occupy the same relative position with the other line, then they're corresponding. So 6 is the upper right angle, 2 is the upper right angle. 4 is the lower left angle, 8 is the lower left angle. So corresponding angles, 1 and 5, 4 and 8, 2 and 6, 3 and 7. So if I ask you the relationship between angle 4 and 8, you would say corresponding. If I ask you the relationship between angle 4 and 5, you would say same side interior. If I ask you the relationship between angle 1 and 4, you'd say linear pair. And if I ask you the relationship between angle 4 and angle 2, you'd say vertical. 4 different relationships. One angle, but compared with different angles. There's actually a relationship between angle 4 and 6 we're going to get to in a second. So we've got same side interior on the same side of the transversal in between the two non-transversal lines. We got corresponding, same relative position with one line as you are in the other line. Could angle 5 and angle 8 ever be corresponding? No, because they're both on the same non-transversal line. You have to be on a different non-transversal line before you can compare. All right, now we've got alternate interior angles. The book does something called alternate exterior angles. I'll make you aware of it, but this is the first book I've ever heard to actually use this as an official definition. All right, alternate interior angles are angles that are on the opposite side of the transversal, yet they're still in the interior. So whereas 3 and 6 were same side interior, 4 and 6 are alternate interior. By the way, 5 and 6 are not alternate interior because they touch the same non-transversal line. 5 and 6 are both on line M. If you want to have alternate interior angles, the angles have to be on the different other two lines. So 4 is on line L, 6 is on line M, 4 is on the left side of the transversal, 6 is on the right side of the transversal, 4 is in the interior, 6 is in the interior. That's what makes them alternate interior angles. It's easy. Alternate means the other one, the replacement, or the thing that I'm not talking about. So alternate, if I'm talking about sides, an alternate side would be the other side. And interior means we're in between the other two lines. So if you actually look at the descriptions, they basically tell you the definitions of what you need to be following to find the lines. And then, of course, the book does alternate exterior angles, which would be angles on the exterior that are alternate, like 1 and 7 and 2 and 8. We won't focus a lot on alternate exterior angles. It's not used a whole lot. So now we have 5 different relationships between angles. Let's see if you can follow them all. What's the relationship between angle 4 and angle 5? Same side interior. What's the relationship between angle 5 and angle 8? Linear pairs. What's the relationship between angle 4 and angle 2? Vertical. What's the relationship between angle 4 and angle 6? Alternate interior. What's the relationship between angle 4 and angle 8? Corresponding. So you've basically got 3 new things to learn to know about the 5 relationships. We already knew about vertical angles and linear pairs, although I'm starting to think not so much linear pairs based on your responses. And then we've known about, or we learned today, same side interior, alternate interior, and corresponding. Make sure you study those tonight and come back knowing how to recognize those tomorrow, because this is important. All right, so right now on a scratch sheet of paper, I'm going to call out a pair of angles, and I want you to write what you think the relationship is. And I'm going to go pretty quick, so you need to keep up. All right, we ready? Here we go. First of all, which line is the transversal? Just write the letter of the line that's the transversal. Next, what is the relationship between angle 2 and angle 3? Next, what is the relationship between angle 5 and angle 6? What's the relationship between angle 7 and angle 6? What's the relationship between angle 1 and angle 3? What's the relationship between angle 7 and angle 3? And finally, what's the relationship between angle 1 and angle 7? All right, let's see how you did. Okay, what's the transversal, Jackson?
R.
R. So R is the transversal. Angle 5 and angle 6. Zep, what's the relationship between those two angles? 5 and 6. Linear pair. All right, angles. Gracie, angles 7 7 and 6.
Same side.
So 7 and 6 are same side interior. I would do S-S int. That's enough information for me to know you meant same side interior instead of having to write out all of those words. Angle 1 and angle 3, Hannah.
Corresponding.
Corresponding, good. I just usually put C-O-R-R-S period. All right. Angle 7 and angle 3 and then angle 1 and angle 7 were the other two that we had. So angle 7 and angle 3. Terrace, what do you think? Alt int. And then Emily, what do you think about 1 and 7? Vertical. All right, so it sounds like we're pretty good. I feel very comfortable about you guys' responses here. Pretty pleased with that. Let's move on. So later we're going to find out that same side interior angles are always supplementary. So if you have two parallel lines, so this is note card worthy. If a transversal cuts two parallel lines, then same side interior angles are supplementary. If a transversal intersects two parallel lines, then same side interior angles are supplementary. That's this postulate right here. We can call it the same side interior angles postulate. Or we can write it out. If a transversal intersects two parallel lines, then same side interior angles are supplementary. That only happens when the lines are parallel. That's not true in this situation right here because line M and line N were not parallel. By the way, from looking at this picture, what visual cue do you think I have that lets me know that line L and line M were parallel? We haven't really talked about it yet, so if you don't know, it's okay.
Two little dashes.
Close. They're not really dashes, they're arrows. So if you look at the picture, if you look at the diagram right here, I've got a line with an arrow on it and another line with an arrow on it. So if they have the same number of arrows pointing in the same direction, that's the notation to indicate that the lines are parallel. All right, the other thing we want to talk about is alternate interior angles. If I have two parallel lines, if a transversal intersects two parallel lines, then alternate interior angles are congruent. So same side interior angles were supplementary, but alternate interior lines are congruent. If you think about that, that makes sense because 3 and 6 would be supplementary by same side. 4 and 3 would be supplementary by linear pair. And if two angles are supplementary to the same angle, then by the congruent supplements theorem, they must be congruent to each other. Well, hey, 4 and 6 are alternate interior angles. So that's why this one gets to be a theorem and the other one was just a postulate. Because I can, once I assume that the other one is true, then I can actually prove this one to be true by facts that I already know. Pretty neato, huh? Yes, Mr. Becker, that's great. All right, finally, corresponding angles are going to be congruent too. If a transversal intersects two parallel lines, then corresponding angles are congruent. We okay? Anybody have any questions? So now not only can we identify all of these angles, but we got facts about them. I can identify vertical angles. What do I know about vertical angles? They're congruent. I can identify corresponding angles. What do I know about corresponding angles? They're congruent. I can identify same side interior angles. What do I know about them? They're supplementary, or they add up to be 180. I can identify linear pairs. What do I know about them? They're equal to 180. I can identify, what have I left out? Alternate interior angles. I can identify alternate interior angles. What do I know about them? They're congruent. All right. Alternate exterior angles are also congruent. Who cares about them? They're like the redheaded stepchild of this stuff. So here's what I'm saying. I'm saying that if you have a situation where you've got parallel lines cut by a transversal, then you should be able to find the measure of every single other angle. Now in this particular picture, I've only got 8 angles labeled, but there are actually 16 angles in this picture. I could find the value of all 16 if I wanted to. Some key things to point out. L and M are parallel. Why? Because they have 1 arrow. P and Q are parallel because they have 2 arrow markings. So this line will be parallel to any other line that has these kind of markings on it. Oh, there it is. And this line will be parallel to any other line that has these kind of markings on it. Oh, there it is. So now what we're going to do is we're just going to use our properties and we're going to go through and we're going to figure out the angles of everything else. Well, the angle measure 105 and angle 7 are vertical angles. What do we know about vertical angles? They're congruent. So therefore, the measure of angle 7 is 105. And wait, 105 corresponds with angle 3, and the lines are parallel. It's also alternate interior with this one, and the lines are parallel. So that makes angle 3 105 as well. And it's vertical with 5, so what's 5 going to be? Hey, it's also corresponding. So see how everything's matching up? Now I've figured out all the angles off of this transversal. Let's do the other transversal. So these 2 lines, L and M, are parallel with transversal Q. So if I asked you what was the transversal in relationship to angle 4, you would say Q, because that's the one that 4 touches. But you could also say L, because that's the one that 4 touches. So it depends on which lines you're talking about. In this case, I want to relate the line M and the line L, so Q would be the transversal in this little system right here. So 4 and 105 are supplementary. What does that mean? So that makes 4 what? 75. And by the way, angle 6 and 105 are alternate interior, so that one's 105. 105 is corresponding with 8, so that's 105. 75 is corresponding with 2, and 75 is alternate interior with 1. So look at that. I just found the measure of all of those angles just by knowing properties of angle relationships when parallel lines are cut by transversals.